All right, Unit 11, Day 2, working with rational functions, again, progressing into graphing more complicated rational functions. So we talked about the reciprocal function last time, right? Which the reciprocal function look like this, right? But not everything that we're going to do is going to look like that, right? So what we have to do then is, like, we're going to see ones that look like these examples right here, 1, 2, and 3, where everything is one fraction. In the reciprocal function, everything's not one fraction. So the process of finding everything is a little bit different, okay? So what we're going to be finding here is we're going to be finding zeros, okay? So remember, zeros are x-intercepts, okay, where it crosses the x-axis. We're going to be finding the vertical asymptote, horizontal asymptote, and the y-intercept, okay? So all of this deals, since it's a fraction, all of it deals with particular areas of the fraction. So the zeros happen when our function is equal to 0, okay? So if we're thinking about fractions, okay, with fractions, if we have 0 over a number or a number over 0, okay, this guy right here is 0. If we have a number over 0, this thing is undefined. Okay? So, if we're trying to find zeros, we are looking for where it's equal to 0. So we are looking for where the top is 0. So the zeros are where the top is 0. Okay? So, in order to find the zeros, we are going to set the numerator equal to 0. Easy enough, okay? So it says find the zeros of the rational function. So we're going to take the numerator, set it equal to 0, and solve it. So x is 2 is the 0, or the x-intercept for that function, okay? For number 2, again, the top, set it equal to 0. Now, this thing we have to factor. This is a difference of squares. So remember, difference of squares, 1 plus 1 minus. Take a square root, x, and then 1. And then set each one equal to 0. So we get -1 and +1. Okay? So going to have to factor. Same thing with 2. If we want the zeros, we only care about the top. So this guy, factor. So 3 terms, multiplies to -2 and adds to 1, would be 2 and -1. So x plus 2, x minus 1. Set those equal to 0. Right, so subtract 2, get -2. And add 1, get +1. Okay? So zeros, the top equals 0. Okay? For the vertical asymptotes, this is where our function is undefined. So fractions are undefined when the bottom is equal to 0. Okay? So we are worried about, for vertical asymptotes, we're worried about where the denominator is 0. Okay? So vertical asymptotes, set the denominator equal to 0. Right? That's the only part we care about for a vertical asymptote. So same things here, right? So we set the denominator equal to 0. So subtract 4. So x equals -4. Same thing. Find the vertical asymptote. So this is also a difference of squares. 1 plus 1 minus, take a square root. X plus 3, x minus 3. set each one equal to 0, subtract 3, get -3, add 1, add 3, get +3. Okay? And then same deal here, right? Vertical asymptotes, so the denominator. Okay? So this is 3 terms, so we big X multiplies to 12, adds to 7, would be a 3 and a 4. So x plus 3 equals 4, x plus 4 equals, x plus 3 equals 0, x plus 4 equals 0. Subtract 3, subtract 4. We got that, okay? So that's how we're going to find these things. Zeros, top equals 0. Vertical asymptote, bottom equals 0, okay? Now, horizontal asymptotes deal with a little bit more stuff going on here, okay? So in this, what we look at to figure out where the horizontal asymptote is going to be is we look at the degree, right? So again, the degree is the highest power. Okay, when it's not factored. Okay, so when it's not factored, we just look at the highest power. When it is factored, we just count how many x's there are. Okay, so rules we got to follow here for horizontal asymptotes. So we check the degree. If the degree of the top is greater than the bottom, so if the top is bigger than the bottom, then there is no horizontal asymptote. So top bigger than the bottom, that means there is no horizontal asymptote. There's something different. We're not going to deal with that at all, okay? We won't have to graph anything like that. Other one, if the degree of the top is less than the bottom, then the horizontal asymptote is the line y equals 0. So if the top is smaller than the bottom, okay? And if the other option is if the top is equal to the bottom, so the degree of the top and the degree of the bottom are the same, then we take the leading coefficient of the top over the leading coefficient of the bottom. So lead co of the top over lead co of the bottom. Okay? And then that's where our horizontal asymptote is going to be. So not really any factoring, anything we got to do here. We just have to look at the degree. Okay? So in number 7 here, it says find the horizontal asymptote for each rational function. So the top here, x times x minus 2, that is factored. So if we look, the degree of the top, there's 2 x's up there, so the degree is 2. The bottom, there's just 1. So in this case, the top is bigger than the bottom. So that tells us that rule means there is no horizontal asymptote. And again, we're not going to have to graph that. Okay, we're going to deal with just 0 or the ratio there. But we look at that. Okay, in number 8, okay, if we look at the degree of the top, okay, we've got the top, degree of the top would be that x to the first. And in the bottom, that's not factored, so we just need to look at the highest power is 2. So in this case, the top is smaller than the bottom. So that automatically tells us it's at y equals 0. Okay, it's at that x-axis, right? And then for number 9, if we look, degree of the top, right? This thing is not factored, so the highest power 2. Degree of the bottom, not factored down there. So highest power is 2. So we take the ratio of the leading coefficients because the top is equal to the bottom. Okay? So we take y equals the leading coefficient of the top over the leading coefficient of the bottom. Okay, so if we look, leading coefficient of the top is a 3, and right here on the bottom is a 1. So we're going to take 3 over 1. So our horizontal asymptote would be at the line y equals 3. Okay, so that's how we're going to find those horizontal asymptotes, is by using those rules, all right? And then for, let's see, numbers 10 through 12, right? We're finding the y-intercept. So finding the y-intercept is going to be the same as it has been for every other function we've worked with. So to find the y-intercept, we're just going to plug in 0 for x, right? So to find where it crosses the y-axis, you just replace x with 0. So in these two, that means we need to find, if we plug in, plug in 0 for x, right? So f of 0 would be 0 minus 2 over 0 plus 4, which would be negative 2 over 4, which if we simplify that is negative 1/2, okay? And then that y-intercept, we used 0 for x, and we got negative 1/2 for y, okay? If we go for this guy, same deal, to find the y-intercept, plug 0 in for x, we go y equals 0 squared plus 0 minus 2 over 0 squared plus 7 times 0 plus 12, right? So this would be 0 plus 0 minus 2 over 0 plus 0 minus 12, which gives us negative 2 over negative 12. And if we simplify that, that gives us positive 1 over 6. So we got 0 for x and 1 over 6 for y. Okay? And then if we go for number 12, if we go y equals, again, 0 squared plus 0 minus 6 over 0 squared. That would give us 0 plus 0 minus 6 over 0. So negative 6 over 0. And remember, when 0 is on the bottom, that means this thing is undefined. We cannot divide by 0. So since it's undefined, that means this thing has no y-intercept. It's not going to cross that y-axis, okay? So that's what we're working with, okay? Next time we're going to work on finding all of this and putting it on the graph, all right? But try out that homework and let us know if you have any questions.